Hi there, and welcome to a new series from Upstream Ag Insights, where we're creating high-quality videos that deliver timeless insight for agribusiness professionals. This is the first in a monthly series. To kick things off, we're diving into just a handful of Deere & Company's more than 10,000 global patent filings. Patent filings offer a rare window into how companies think about the future, highlighting the technologies and systems they're investing in before they ever hit the market. We're specifically going to look at precision and autonomous technology. From fleets of autonomous robots to multi-legged designs that rethink how machines move across fields, to smarter soil testing, predictive soil maps, and the next evolution of See & Spray, these patent filings reveal Deere's vision for the future of precision agriculture. Some may never make it to commercialization, but all of them show how the company is pushing the boundaries of farming. My name is Shane Thomas, an agribusiness professional focused on synthesizing what's happening in agribusiness for agribusiness professionals trying to stay ahead. Upstream Ag Insights itself is a weekly newsletter highlighting essential news and analysis for the agribusiness leader. It focuses on innovation and the implications of that innovation on agribusiness professionals. If you want to go deeper, there's Upstream Ag Professional, the premium membership trusted by thousands of agribusiness executives, founders, and innovators across the value chain. In the professional edition, you get weekly premium analysis, which has high signal commentary on the most important moves in crop protection, seed, fertilizer, and ag tech from the week that was. Access to the visualization hub, which has charts, frameworks, and data you can use in your own decks, team meetings, and strategy sessions. And a report hub, exclusive deep dives on things like biologicals, precision technology, mental frameworks for agribusiness professionals, and more. There's also an audio collection where each week the insights are delivered in audio form so you can learn while on the move. And finally, recently launched is Ask Upstream, a powerful LLM trained on the Upstream archive that gives you best-in-class, context-specific answers about agribusiness for business development, strategy, market intelligence, or if you just want to better understand what's happening in the industry. If you're serious about your career and want to make sharper decisions, Upstream Ag Professional is something you should have in your toolkit. You can join today by heading to upstream.ag and start getting access to the tools, ideas, and insights that the most forward-thinking people in agriculture are already leveraging. Today, we're going to talk about the Deere patent filings, and those go from field bots to soil mapping, to soil testing, to the evolution of See & Spray technology. But first, we're going to do an overview of John Deere. And when you think about John Deere or Deere & Company, the first word that comes to mind is probably green. The next might be innovation. The company's story itself begins with John Deere, a blacksmith in Grand Detour, Illinois, in the 1830s. He was simply building everyday tools like pitchforks and shovels for his farming neighbors, but he noticed something. Farmers in the Midwest struggled with sticky prairie soil that clung to their wooden and cast iron plows. Every pass through the field meant stopping to scrape the soil off by hand. It was slow and exhausting. Deere saw the problem and decided to solve it. In 1837, he crafted a plow out of a broken saw blade, polished the steel, and curved the design. This allowed the soil to slide off effortlessly, and the result was what became known as the self-scouring plow, a breakthrough that transformed farming efficiency. Farmers quickly recognized its value, and Deere's reputation as an innovator was born. The ethos of solving farmers' problems through innovation has carried forward for nearly 2 centuries. Deere has evolved from steel plows to tractors, combines, sprayers, and more. And now they're in software, artificial intelligence, and have advanced into services like John Deere Financial. They've not only focused on equipment, but also on business model innovation, being one of the first to move through to annual recurring revenue models in their technology segment. To see how innovative John Deere is, we can look no further than to its patent filings. Patents may sound abstract or complex, but they're actually windows into how a company thinks. They reveal what technologies are being developed, which problems leadership considers important, and where resources are being directed. Not every patent will reach the field. Some are defensive, others exploratory, but collectively, they sketch out the boundaries of a company's innovation frontier. For John Deere, these filings underscore their commitment to advancing precision agriculture, robotics, and the role of soil in crop production, something I'm passionate about as an agronomist in a previous life and still focused on that segment of the industry. It's notable that Deere isn't only looking at machinery, they're actively shaping the interface between agronomy, digital tools, and autonomy. In my opinion, Deere and their equipment company competitors have the ability to influence agronomic decisions and tools as much or more than fertilizer or crop protection or seed companies in the future. Why does it matter? Because the challenges facing farmers today are continually evolving and they will need access to new tools. Deere's patent filings provide a preview of those solutions. Some patent filings focus on robotics and autonomy, enabling equipment to perform more tasks with less human input. Others address soil and crop interaction, making the machinery smarter about how it engages with the ground and the plant. Collectively, they point to a strategy that recognizes farming is as much about the data and decisions as it is about horsepower and steel. So the first patent, field of bots. For decades, John Deere has been known for building bigger and bigger machines, but their patent filings show they're also thinking about something very different. Fleets of smaller semi-autonomous robots. The idea is straightforward. Scout robots roam the field using cameras and sensors to collect data on plant conditions, spotting weeds, disease, or even identifying where beneficial insects should be released. That data is then passed to worker robots, which carry out the tasks like spraying or pruning. Each job is assigned a performability score. If the robots can handle it easily, like spraying a pesticide, they do it autonomously. If the task is more complex, it gets flagged for human oversight. The operator sees a ranked list of priorities and can jump in where they're most needed. And I think it's important to note that the human is always involved. To make it even more efficient, operators can pre-program movement plans or use augmented and virtual reality to visualize the tasks. The result is a system where a single person or small team can manage an entire fleet. While this concept feels especially suited to orchards or high-value crops, it hints at how Deere is thinking about autonomy and precision even in today's large-scale machinery segment. And I think that's an area I focus the most on is the large-scale row cropping in North American agriculture. And when we think about these small robots, and there's some other patents coming up, patent filings around that, is these don't necessarily need to be standalone. It might be hard to envision a 10,000 acre farm just having small little robots, and maybe that will come to fruition. But what's also interesting to consider in this context is how you can have a large machine that might be 60, 80, 90, 120 feet in scale and size, or from the swath that it actually can influence every pass through the field. But how can these smaller robots be tethered to the larger ones, where for large scale segments of the operation, the large machine is still used, but around power poles or sloughs or various difficult to get to parts of a field, these smaller robots could be used. And so it's interesting to think about it as an ancillary component, not necessarily just standalone. And I think one of the interesting components that came through in this patent filing that comes through in a bunch of the patent filings we're going to go to today is this theme of increasing precision. Deere's talked about the progression from farm to field to plant by plant management. And the theme of their patents takes it even further to plant segment, being able to manage even more precisely. In the previous patent filing, there's a note talking about how the data collected can even pinpoint specific parts of plants that need attention. And I think parts of the plant is that theme in John Deere's patent filings that come across throughout all of these, where they aren't stopping at just the plant itself, but getting into segments, which might sound unnecessary to some, but it becomes compelling when we start thinking about the evolution towards see and spray for insects, for example. And so we'll touch on that a little bit more in a bit. Next, John Deere's patent for multi-legged robots. It's one of the more unique visions for farm machinery, and it signals how far automation could go in agriculture. Unlike tractors and sprayers that we're used to, these machines in the filing appear designed to move on multiple legs rather than wheels or tracks. That design gives them two key advantages. They can navigate uneven terrain with greater mobility, and they spread their weight across multiple points of contact, meaning less compaction, which is also a challenge for farmers trying to preserve soil health and ultimately productivity of that soil. But mobility is only part of it. Deere's patent filing envisions these robots as precision tools. They're not just scouts collecting data, they're built to perform field work directly, from planting seeds to applying fertilizer to removing weeds. Their modular design allows farmers to mount different tools or sensors depending on the job. While it might seem far-fetched today, it could be a sprayer for fungicide one day, or a metal alternative weed management system the next, making the same machine serve multiple purposes. To make all this possible, the robots rely on advanced control systems. Cameras, sensors, and onboard computing let them navigate autonomously, assess conditions, and adapt their movements or actions. A farmer might only need to step in occasionally, while the machines handle much of the repetitive, precise work. When you put this in context with Deere's other robotics patents, it reinforces a very clear theme. Autonomy, precision, and versatility are at the center of Deere's innovation roadmap. These machines are built to create systems to reimagine how farming itself is carried out. Next, soil is the foundation of every farm, but our ability to measure and manage it has always been limited. And as I mentioned earlier, as an agronomist, spent a lot of time taking soil tests or soil samples and then looking at the soil tests themselves and the results and creating fertility recommendations. And soil is a passion of mine. And traditional soil sampling is manual, time consuming, and low resolution. On average, one soil test represents just 2 pounds out of nearly 2 million pounds of soil in the top 6 inches of an acre. And so if we think about that on just an acre basis, that's about 0.00001% of the acre, just on the acre. So if you have 160 acre field, all of a sudden you're 0.0000000. You get even more diluted on that. And so that really shows just how low resolution the testing is today. And to make it worse, sampling often happens months before planting, meaning nutrient levels may have already shifted by the time the crop goes in due to volatilization, mineralization, a bunch of different things. And so John Deere's soil sensing patent aims to change this. Instead of relying on random or grid-based samples, Deere's system uses advanced imaging sensors mounted on tractors or robots to scan fields in real time. These sensors would assess plant health, identify the most valuable spots for soil sampling, as just a couple examples. Robotic arms would then collect the samples, or in some cases, analyze the soil directly in the field in real time. This approach unlocks smart targeted selection. Rather than pulling a few random samples, the system hones in on areas where plants show stress or unusual growth patterns. It would then measure moisture, pH, organic matter, and nutrient levels, cross-referencing stressed plants against healthy ones to paint a far more accurate picture of what's happening below the surface that's impacting those plants. That's real detailed insight. The big win here is, again, precision. By integrating plant-level data with soil insights, Deere is pushing farming toward plant-specific management and, as alluded to earlier, specific plant segment management. That means more efficient fertilizer use, better seed placement decisions, and the ability to respond to issues in real time. We can see how this can help support much of their LEAP's ambition target for 2030. For example, one of their ambitions that they released in 2021, where they talked about their goals in delivering precision technology to farmers and to the market, and has sustainability targets there as well as recurring revenue targets and those sorts of things. They want to, and I quote, improve nitrogen use efficiency per unit of output by 20% by 2030 relative to the 2021 baseline, end quote. Better soil testing and precise application capabilities help support that ambition and help support farmer profitability. Nitrogen, for example, often makes up the biggest expense of a farmer's annual input costs, sometimes 20+% of that total application. When you start putting down 250 pounds of urea, it can add up really, really quick at 55, 60 cents per pound, for example. And so it's another example of how Deere is evolving precision agriculture, not just making machinery smarter, but making the soil to plant connection more actionable than ever before. And that's where, when we look at the soil variability, I think this is one image that I've tried to create to illustrate just how variable soil can be. And if we look at this image, I have a horizontal 3-inch variation and then a vertical 3-inch variation. And so you can see how each 3 by 3-inch segment is a different color, and that's intended to represent the variation in different nutrient levels, organic matter levels, pH levels, all the above, texture. And that shows how variable soil can be across an entire acre, but let alone that, you could do a square foot by square foot segment and see how the variation is just on that small of an area. Soil is incredibly complex, and we make decisions off of just 1 to 2 pounds of soil that are taken from all over a field and then mixed together. And so you can see how there's variation, and that's good enough in some instances and is better than nothing at all in a lot of instances too. But we can be better, and there's even companies out there planning to focus on this area, like TerraBlaster, which uses NASA developed laser technology to instantly analyze soil. By blasting the ground with laser pulses, it reads the soil's nutrient and chemical makeup in real time, or at least that's the intention. It gets mounted on farm equipment, creates high resolution soil maps on the go, which is faster, cheaper, and more detailed than traditional lab soil sampling. And the goal is ultimately to reduce uncertainty in soil fertility decisions and enable real-time, precise fertilizer application, much like we're seeing from Deere. And I think this really ties into their next patent filing, and that's where Deere envisions a system where soil isn't just tested once or twice a season, and twice might be generous. And actually, if you look at the most recent data, I believe in the US is something like 20 or 30% of soil is tested every 2 to 3 years, something like that. And so you can see where it's not even every year the soil gets tested. And Deere wants to make it continuously monitored in real time every pass. Sensors mounted on tractors, planters, sprayers, or even UAVs could gather data on soil moisture, nutrient levels, compaction, and temperature, as a few examples. That data is then streamed to a centralized cloud-based platform. Machine learning models would then take those readings, combine them with historical data, and forecast how soil will behave under different conditions. Say a heavy rain event or a stretch of drought. The output creates more than a map, but actionable recommendations. The system could suggest changing tillage depth, for example, adjusting fertilizer rates on the fly, or even altering seeding density by zone. And because it integrates directly with Deere's equipment, those insights can translate into those field actions. And we could even take this a step further to seeding varieties, for example. And so the broader potential comes when these high resolution maps are layered into Deere's existing digital tools, which is where Deere has a really interesting and compelling ecosystem, kind of as a baseline with John Deere Operations Center, but they've acquired other assets like Harvest Profit, where you can start to connect this soil information and agronomic actions directly to the profitability forecast. So Harvest Profit is an accounting and financial farm management software that they acquired at the end of 2020. And when you start to layer in agronomic and field level and applied level insights with the financial aspect, you can start to see which areas are more profitable, which are unprofitable, which need specific actions so that they can be made more profitable. And so that's where you start to really get to precision farm management. And that's where I get really excited. And I think it highlights just how critical soil understanding can be, because you can't manage your finances without managing the soil. That's kind of the core base asset that a farmer has. And so I think Deere's patent shows a path toward making soil a living, dynamic data layer in decision making. And they're looking at bringing the tools in to assess and understand and amplify the opportunities to deliver new ways that farmers can manage and obtain knowledge around this asset. And that brings us to the next step in John Deere's See and Spray technology. And this to me is one of the most compelling patent filings that I went through of John Deere's. It begins to describe a smart spraying system with multiple tanks that can hold different types of pesticides. As the machine moves through the field, sensors detect pests in real time, identify what they are, and then select the right pesticide from the tanks to spray precisely where it's needed. Sounds a lot like current See and Spray, which for those unfamiliar, See and Spray is effectively a sprayer with a reinforced boom that also has cameras that can see weeds and what's going on in the field, that has trained artificial intelligence to be able to determine the weed versus the crop, and then turn nozzles on or off accordingly and be able to cut down on spray, but also manage crop stress, be able to better manage resistance and costs and those sorts of things. And I think what makes this patent filing most interesting to me is that it's an expansion beyond just herbicides. For large crops like corn, the system can adjust nozzle height, angle, and pressure to target specific plant parts, whether that's applying fungicides to lower down on the plant, because if you have a only xylem mobile or a contact only fungicide, you need to have coverage at other parts of that plant rather than just the top of it. And so I think that's really crucial when you start to think about it from a fungicide perspective. But then it's also important from an insecticide perspective, where you could apply directly to pests where they are based on what the cameras are seeing, or even more targeted biostimulant applications to try to hit more parts of that plant. And I think this is important because one challenge for See and Spray adoption has been its focus on herbicides alone. And that's not a knock on John Deere or their capabilities. They had to start somewhere. But if you talk to farmers, some of them hesitate to pay for a premium system that only improves one segment of crop protection. So only the herbicides currently today are being augmented, broadly speaking. But if you broaden it to fungicides, insecticides, biostimulants, and more, fertilizer, for example, Deere increases the potential ROI and makes this technology more attractive across more acres and more farms. And Deere's already collaborating with companies like Interplant and Syngenta on fungicide applications to be able to better understand what a plant is feeling and where and when it's feeling it. And this patent shows they're thinking about vertical and dynamic spraying, not just top-down coverage, which I think is crucial when we start to think about fungicides and insecticides. See and Spray is really moving toward becoming a comprehensive crop management tool, and patent filings like this one illustrate how Deere is preparing to unlock greater efficiency, savings, and agronomic impact for farmers. And I do think that's kind of a crucial takeaway, where this gets thought of as a crop protection sort of tool, and there's a ton of validity to that, specifically when we start just thinking about it from herbicides. But to me, what See and Spray really will become and is becoming is a Swiss Army knife for crop management. It becomes a tool to manage crop health, to manage insects, to manage fertility, to manage all of these different things. And that is where you start to get a ton of upside for the farmer over time. And so with that, John Deere's latest patent filings highlight where the future of precision ag is headed. And I think if we think about it from three segments, the first of where we covered today was really like automation. Deere envisions these fleets of small robots that, and even multi-legged machines that can help reduce labor needs while bolstering or boosting precision across farm operations. Second, we see soil intelligence, and Deere's tackling one of farming's biggest blind spots, and an area that I'm really excited to see progress in the coming years with real-time soil testing and predictive mapping, moving beyond today's slow, low-resolution sampling towards continuous, actionable testing and ability to take action. Lastly, the next generation of crop management. Deere is evolving See and Spray to target specific plant parts and expand beyond herbicides, bringing fungicides, insecticides, and even biostimulants into the mix. Together, these innovations reveal a company positioning itself to redefine how farmers manage fertility and crop health in the decade ahead. And as we see from the image shown, Deere is pushing the envelope on precision tech and adoption already. Deere has nearly 500 million engaged acres, meaning farmers using digital tooling at least once on the acre per year, more than any other ag company, and is nearly 800,000 connected machines, with that set to grow in the coming years thanks to collaborations with the likes of Starlink. That concludes the first video on innovation in agriculture. Thank you for listening. If you have any questions or comments, please send me a message at shane@upstream.ag, and check out upstream.ag to subscribe to this kind of information and get it directly in your inbox every Sunday, along with 21,000 other ambitious agribusiness professionals from around the world.